So for this section of the lesson, we are going to define the radian measurement of an angle. A radian is a unit of measure, like a degree is a unit of measure. And the definition of the radian measurement of an angle is an angle in standard position that intersects a circle, and its measurement is the arc length of, so if I intercept this circle, it is the arc length here, and the relationship I get is that the arc length is r times theta, where theta is in radians. Okay, so if I want to know what theta is, divide both sides by r. Theta is equal to s over r. Okay, and if r happens to be 1, then theta is just going to equal the arc length. So let's think about this. Let's make r 1. Okay, and then S is how far around the circumference of the circle, that portion that the angle traveled. Well, how far, what's the circumference of a circle's thing? Well, you know, a circumference is equal to 2 pi times the radius. So I can call this circumference the arc length for a circle. So I'm going to call that S for the circle is 2 pi r. We said r is 1. So the arc length for a circle is 2 pi. So that means the angle for a whole circle is 2 pi radians. So if I were to draw this circle going all the way around, I would say that that is 2 pi radians. So if I start out at 0 radians and go all the way around, I get to 2 pi radians. Well, let's look at this relationship here. Well, half of a circle, what's 2 pi divided by 2? Well, that would be pi radians. Okay? What you need to be able to do is convert between radians and degrees and radians. And we're going to use the fact that a whole circle has 2 pi radians, or a half circle has pi radians. So I know that my angle in radians is equal to my angle in degrees. Okay, now let's see what kind of relationship. Angle in radians over how much does it, we'll just put pi, radians, is equal to my angle in degrees over, well, how many degrees is pi radians? 180 degrees. Okay? So we know that pi radians is equivalent to 180 degrees. That's the same thing that's saying 3 feet is the equivalent to a yard. I'm not saying that pi is equal to 180, but I'm saying that pi radians is equivalent to 180 degrees. So let's think about that. If pi radians is equal to 180 degrees, divide both of these by 2. What's 180 divided by 2? Well, that's 90. So I know 90 degrees is equal to pi halves radians. Okay, let's divide it by 2 again. Pi halves divided by 2 would be pi fourths. 90 divided by 2 is 45 degrees. So a 45 degree angle would be pi fourths radians. Other measurements that you should know is, well, if we know pi radians is 180 degrees, if I divide both of these by 3, I get that pi thirds radians is equal to 60 degrees. Divide both of these by 2, and I get pi 6 radians is equal to 30 degrees. And you should be able to come up with every multiple of pi 6, pi 4ths, and pi 3rds all the way around the circle. Okay? And what their equivalents are. So pi 6 we said was 30, 45, 60, 90. Okay? If I take 1 pi 3rd and add another third to it, I get 2 pi 3rds. And 2 times 60 is 120. 1 pi 4th, 2 pi 4ths, 3 pi 4ths is 90 plus 45, which is 135. So I've got 1 6, 2 6, 3 6, 4 6, 5 pi 6, which would be 150 degrees. Then we had 180 degrees. And I can do the 30 degree, 45 degree, and 60 degree in every quadrant. And you are going to be expected to know these relationships without the use of a calculator. These are so commonly used, you're expected to know them without a use of a calculator. So I got 5 pi 6, 6 pi 6, 7 pi 6, 8 pi 6, 9 pi 6, 10 pi, so this one is 12, so that would be 11 pi 6. Okay, pi 3rds, 2 pi 3rds, 3 pi 3rds, 4 pi 3rds, 5 pi 3rds, so 3 thirds, 4 thirds, let me do this one. 3 quarters, 4 quarters, 5 pi 4ths, 6 pi 4ths, 7 pi 4ths. So that would be 6 thirds. So this one would be 5 thirds, 5 pi thirds. Angle measurements, 210, 225. 180 plus 60 is 240, 270, and that is 3 pi halves. It's 270 degrees. 270 plus 30 is 300. 270 plus 45 is 315. 360 minus 30 is 330. That's 0 degrees and 360 degrees. And I can keep going around because just like coterminal angles with degrees, I can also have coterminal angles with radians. So these are the expected conversions I expect you to be able to do without a calculator. I'm going to erase the board with the exception of this circle, and I'm going to do some example problems converting between degrees and radians degrees, where you're allowed to use a calculator. So the directions for guided practice 5 say to convert 125 degrees into radians. So this is the way I always set them up. I go blank over pi is equal to blank over 180 degrees. I put, if I'm given degrees, I write the degrees on top. And then I'll put the x for what I'm solving for. Do not use the calculator and put multiplied by pi to get an answer. What you're going to do is simplify this fraction. Yes, I'm going to multiply both sides by pi. These cancel. And I would get x is equal to something times pi. Well, I see that 5 goes into both of these. 5 goes into 125 25 times. I see that 5 goes into 180, looks like 36 times. And my answer would be 25/36 pi. Okay? I do expect you to be able to simplify the fraction. You can use the calculator to simplify the fraction, but do not multiply it by pi unless I ask you for an approximate result. If I ask you for the approximate result, do not give me an equal sign, but give me an approximately equal to, and use the pi key on the calculator to do this. 25 divided by 36 times pi. It's approximately 2.18, and they'll tell you how many units to round to. And notice I started out with units of degrees. I ended up with units of radians, but I did not put RAD or radians after this on here. Radians is the most widely used measurement of angles in mathematics. So we do not even put the radians on here. So if I give you an angle measurement that does not have a unit, it's implied to be a radian unit measurement. Guided practice 6. It says take negative pi twelfths and turn it into degrees. So I set up my proportion, and I know that pi is equivalent to 180 degrees. I want to find degrees, so I'm going to make that my x. And I'm going to put negative pi twelfths over here. First thing I'm going to do is simplify the left-hand side. Pi divided by pi is 1, so I get negative 1/12 is equal to x over 180 degrees. Multiply both sides by 180 degrees. And 12 goes into 180 degrees 15 times with a minus sign. So my answer here would be negative 15 degrees. You can check that with a calculator. 180 divided by 12 is 15, and don't forget the minus sign. So again, the steps are to write something over pi radians is equal to something over 180 degrees. Fill in your known value on the appropriate side. Then the other side that's left will be the area, this piece that you are solving for. And next we're going to do some applied problems using radian measurements. So the two applied problems I'm going to have to deal with either given an arc length or to find an arc length. I want you to be able to find the radius or give the radius, and also be able to calculate the area of these pieces. What I'm going to call these slices of a circle or a piece of pizza here, those are called sectors. Okay, and let's think about this. We have the formula for arc length. Arc length is r theta if theta is in radians, but I don't remember that formula that way. I know that arc length is the circumference of a circle divided by a whole circle. So arc length is the circumference of a circle divided by a whole circle. So arc length is 2 pi r. Well, in radians, the a whole circle has 2 pi radians, and in degrees, a circle has 360 degrees. So if I simplify each of these formulas, r times theta, I forgot my theta. So those would cancel, and I get s is equal to r theta for radians. I can do some canceling here. 2 goes into 360 180 times. And I'd get pi r theta divided by 180 degrees. I still don't memorize those formulas. I just use that relationship every single time. So for these questions in this one, I want to know the arc length and then the area of the sector. Well, arc length is the circumference, 2 times pi times r. That's 180 feet. Divided by how many degrees in a whole circle? Well, times the 50 degrees. Divided by how many degrees in a whole circle. So it's circumference times the fraction of the circle. Well, 2 times 180 is 360. 360 divided by 360 is 1. The degrees cancel, so I have 50 times pi times feet. The exact answer would be 50 pi feet for my arc length. And again, you could stick that in the calculator to get me an approximate answer. Let's think about area of a circle. Well, area is equal to pi times radius squared times a fraction. Well, it's a fraction of 50 degrees over 360 degrees. So I'm going to use a calculator to do this portion of the work. So 180 squared times 50 equals, divided by 360, is 4,500 pi feet squared. And again, if I ask for an exact answer, leave pi in the answer. So the area of a sector is the area of a circle times a fraction. An arc length is the circumference of a circle times a fraction. So that's the first example. The next one here, I want to find the area, and I want to find the radius. Well, radius, I'm going to have to rearrange my equation. So I know that the arc length, 500 feet, is equal to the circumference of a circle, which is 2 pi r, times a fraction. Well, the fraction is 2 pi thirds divided by how many radians in a whole circle? 2 pi. So I want to solve this equation for r. So first thing I'm going to do is simplify the right-hand side. These cancel, and I'm left with 500 feet equals 2 pi r over 3. And I need to multiply both sides by 3 over 2 pi. So I get 3 over 2 pi times 500 feet equals r. So that's 1,500 divided by 2, which is 750 over pi feet. And that's an exact answer. Next thing I want to know is what the area. Well, the area is pi r squared times a fraction. So I'm going to erase the work for the first example. The area is pi times radius squared times a fraction. Well, it's 2 pi thirds over 2 pi. Let's cancel, this is radius squared. Let's cancel what can cancel. This 2 pi cancels with this. This whole thing becomes 1 over 3. So what I end up with is pi times 750 squared feet squared over 3 pi. These pi's cancel. Then I end up with 750 squared divided by 3, which is 187,500 square feet. So again, on these examples, just use your circumference formula and your area formula and multiply them by the fraction of the circle. The third part for lesson 9.2 is using trig functions using radians, which will be part C of this series.